The United States is days away from sending astronauts around the moon in the first such mission in more than 50 years. We will discuss that later in the show. But first, China is preparing for a number of important missions this year, including to the moon. The country already broke the record of rocket launches in 2025. A common event in China. Last year alone, 92 rockets were launched, bringing more than 300 satellites into orbit, delivering probes into space and even humans to the Chinese space station. The Shenzhou 20 crew spent 204 days in orbit, setting a record for the longest single mission duration in the history of China's manned space program. In 2026, China will attempt new milestones in space exploration. The Tianwen-2 probe, launched last May, will aim to reach the mysterious asteroid Kamoleva and return with images and samples. The asteroid has an orbit around the Sun similar to Earth's, and one theory is that it's a piece of the Moon. Speaking of the Moon, the Chang'e 7 mission will send an orbiter, a lander and a rover to explore the south pole of the Earth's only natural satellite. It will search for evidence of water and prepare for future manned missions. China is also getting ready to launch the Xiantan telescope. It will orbit alongside the Tiangong space station, making it easier to dock for repairs or even upgrades. The Xuntian has a field of view 300 times larger than the Hubble telescope and is expected to make major contributions to the study of galaxies. To discuss the Chinese space program, we welcome Fan Zhang. He is an associate professor of astronomy at Beijing Normal University. And here in Washington, D.C., Amitabha Ghosh is a space scientist working on NASA Mars missions since 1997. Thanks to both of you for joining us. Fan Zhang, let me start with you. As I mentioned, China broke a record in 2025 with 92 rocket launches. So what's ahead? How does China build on that?
Right. So next year, you're going to be seeing a lot of activities. First, in terms of launch vehicles, there will be over 10 new rockets. Among them, the Long March 10 rocket that will be used for going to the moon. So the a sort of straight down but reusable version of that will launch towards the end of the year. And also there are a lot of commercial companies launching their reusable rockets. So at the end of the year, you may have China may have a bunch of reusable, cheap ways of launching into space. So I think that's the most important thing, building the capabilities for even further developments.
So Fan Zhang, are most of these launches that we are going to be seeing, will that be to put satellites up in space, or will they be also used extensively for space exploration?
So there is a deep space aspect of it. For example, the Long March 10 has two versions. The more powerful version has 3 first-stage rockets binding together, kind of like the Falcon Heavy being like 3 Falcon 9s bind together. So that will be used for sending humans to the moon. But there's also a stripped-down version that's for low Earth orbit, and also the commercial ones are also mostly for low Earth orbit. So China is going to be launching a lot of satellite communication constellations up into space. So cheap way of doing that is paramount at the moment.
Amitabha Ghosh, good to have you with us. Now, those launches that I spoke about, 92 and even more in 2026, a little more than half, 50, will be commercial. That shows the sustained and rapid growth in this sector in China, and there's been research and tests in reusable launch vehicles. It's also advanced very rapidly in the past year. What does this tell us about the technology and the advances in technology that we are seeing in China?
Right, so I think it's a general trend. So it's I think globally you see this trend of reusable launch vehicle, and the reason is very simple. If you reuse the launch vehicle, you save maybe 90 or 95% of the cost. So even in the US market, you'll see like SpaceX has dominated and Falcon 9 is dominating the launches. It's because you make this at a very economical price if you reuse the launch vehicle naturally. And so Blue Origins, for example, is also trying to do that. So China's foray into reusable launch vehicles is very exciting. And so I think if you go 10 years later, just like electric vehicles is the rage in the automotive sector, reusable launch vehicles will be the standard going forward.
All right. And Amitabha, in terms of these reusable vehicles being used, are they far more powerful in terms of reach and also in terms of durability?
No, I think the reach is perhaps the same. I mean, you're just reusing. See, when you had like 10 years back, you make a launch vehicle, the launch vehicle gets destroyed, you go back to the factory, you have to make another one, and then that gets launched. So that there's a finite time required to assemble it. Here, the launch vehicle comes back and it goes again. So you have to be very careful how it comes back, and it has to land somewhere. It may be a raft in the ocean, it may be on Earth, but the reach is the same. I mean, it's just that you choose not to destroy it, you choose to reuse it. So the reach, it is equally powerful. It's everything is the same, but it just is being reused.
Zhang, getting back to what's in store for this year in the Chinese space program, last year China launched a probe, the Tianwen-2, which will get really close to this very mysterious asteroid, which is known as Kamoleva. What is the importance of that mission, and what do we know about this asteroid?
Right, so that's the choice of that particular asteroid is mostly because it's easier to get to. It's kind of a pseudo satellite of Earth. It doesn't orbit Earth per se, but it's orbiting the sun with the same velocity as Earth, so it stays close to Earth. So it's easy to get to and get back all in one go. That's the main reason. But this asteroid, being in such an interesting sort of syncrasy with Earth, may be due to it being part of the collision that formed the moon in the first place, which means scientifically it's fantastic if you can go there and collect some samples, and if that samples looks anything like the moon, then best theory holds water. And then we learn a lot more about how the Earth-Moon system is formed, and from that, you can infer further geological information on these two sort of celestial bodies, and that would boil down to interesting knowledge about Earth.
So what you're saying, Zhang, that this could be a piece of the moon that broke up at some point and is now orbiting on its own.
Right. So the leading theory for how the moon forms is a Mars-sized protoplanet hit Earth and then sort of smash everything to pieces. And then some of the pieces close enough to Earth forms the moon. And during that process, some piece may not stay close enough and just fly off. And this could be, this is one theory. It may or may not be valid, but it's interesting enough to go and take a look.
Amitabha Ghosh, China will also launch a mission to the moon. It will have an orbiter, a lander, and a rover as well. That rover will be used to explore the surface of the moon. Now, it will search for evidence of water. This is on the south pole of the moon. How significant is that?
Well, so we have found ice on the moon at the Shackleton crater. Why is ice water so important? Imagine doing a moon mission or setting up a base there and you're having to carry all that water from Earth. So having ice and having a way to access that ice for water is very, very critical to the success of a lunar base or for a long-term human mission. So that is why the race for water is so critical. And the Shackleton crater is of interest for the last 20 years, and it has been imaged. So there are some permanently shaded areas of the crater where there may be ice. So I think it's very exciting. I think China and the US and India and multiple nations are trying to study the South Pole because of this reason.
Zhang, of course, these missions into space will also be carrying payloads, scientific instruments in most cases, and these scientific instruments will come from many countries. They will come from Russia, Egypt, Bahrain, Italy, Switzerland, and Thailand all have experiments on board these flights. How important is this kind of international cooperation?
But eventually, what China is trying to establish on the moon is something called the International Lunar Research Station. Well, there's practical reasons, because when you do science, the scientists, there's only so many people, very few people in the world that specializes in a particular scientific direction, and they're all spread it out across the world. So to put together a whole mission and then to dig up valuable science, you just have to do international collaboration. So that's the main reason. And also the for the International Lunar Station to work towards the future, then these earlier missions, the probes, you want to include everybody early on, so they gradually sort of increase their level of integration. So from individual instruments, that if it doesn't turn up, the whole mission is not jeopardized. And then later on, the vital components of the mission, and then even the conceptual design of the whole station. So there are different levels of collaboration, and you want people in the lower tiers straight away, and then gradually move up.
Right. Now, that research station, Zhang, that will be built on the moon, I would imagine it will be constructed there piece by piece with components taken from Earth. How far are we away from that?
Right. So actually, this year's Chang'e 7 will form the first piece of the station. So the station is not going to be like a base with housing dormitories and labs and all that. It's just going to be a whole bunch of different satellites there, but they're interconnected. For example, the next mission, so the Chang'e 7, this year's mission, is going to be mostly looking for water. And then the next one, Chang'e 8, will be bringing a sort of robots that are basically a giant power bank. It moves around between all different satellites, different components, and charge them up. So once all this different infrastructure is in place, the humans will go, and then that'll be before 2030. And after that, there will be likely 2 more technology demonstration missions, bringing things like communication towers, and all these little pieces, they linking together, they form the basic form of the station. So that will already be in there before
right.
30. Yeah.
Amitabha, let's talk about the Shuntian telescope. Now, it's about the same size as the Hubble, as I mentioned, but it has a view that is 300 times larger. So what will that tell us? I mean, how deep would we be able to look into space?
We will be able to, so the field of view is much larger, but we will have data of the universe. And why is this so interesting and important? All these space telescopes that we have sent, right? It's because we have 1 trillion galaxies, and each galaxy has probably a trillion stars. So you have 10 followed by 22 zeros or 24 zeros. That's how many stars we have in the universe. And so we cannot really visit any of them because our space navigation is just very slow. So the way to understand the universe is through these space telescopes. And I think this will be a step forward. One of the perplexing questions is the presence of dark matter. So apparently there's matter which does not emit, transmit, or absorb light. And so you don't know of their existence, except that their gravitational effect is seen. And so the only way to find dark matter or confirm dark matter is to see, is to map the universe or the local part of a universe and see, does it make sense without dark matter? So, so this telescope, as well as I guess data from Hubble and Webb telescope, all these data from the space telescopes help us confirm whether will hopefully help us confirm one day whether dark matter is really present or not.
Okay, we have to leave it there for now. Amitabha Ghosh, Zhang, thanks to both of you for being with us. Time now to take a look at the NASA mission Artemis 2. Last week, the rocket that will take humans close to the moon again rolled out onto the launching pad in the US state of Florida. No official launch date has been set, but the first window opens on February 6th. To talk about that and more, let's bring in our second panel. From Florida, John Zarrella is a journalist covering the US space program, and Fraser Cain is founder and publisher of Universe Today, a space and astronomy news site. He joins us from Vancouver. Thanks to both of you for joining us. John Zarrella, great to see you. It's been some time. Now, you are a few kilometers away from the Kennedy Space Center in Florida. In fact, you'll be able to see the rockets that will take men and a woman outside of low Earth orbit. The Artemis 2 mission will take astronauts around the moon and return to Earth. How significant is that coming 50 years after the first manned mission to the moon?
Yeah, it's been quite a while, that's for sure. It's incredibly significant. First of all, they have flown the SLS, the rocket system, Space Launch System, and the Orion spacecraft a couple of years back on a robotic mission. Basically, there were no crew on board to test the systems out. But now you put a crew on board, and you are going to go further away than any human has ever been because of the kind of orbit that Artemis 2 this mission is going to take. And you're going to have to check out the avionics, the propulsion systems. You're going to have to check out life support, most importantly. And then if the mission, the 10-day mission, goes well, when they get back, then they can start preparing for Artemis 3, which would actually land, astronauts on the moon. They're hoping by 2028. But that is really tight, and it's quite difficult simply because, well, one of the basic reasons is the lander that would take the astronauts to the surface of the moon is supposed to be built by SpaceX, which is a variation of its Starship, the big one that Elon Musk hopes will take humans to Mars. Well, they haven't perfected it yet. It's a ways away. So if that doesn't meet the timeline, then the astronauts aren't going to the moon by 2028.
So let's say it is built in time, John. What will the goal of that manned mission to the moon be? Well,
they're going to try to land. Everybody wants to go to the lunar South Pole. That's the key. Even China is planning another robotic mission later this year that would go to the South Pole, to the Shackleton crater, and look for water ice. The idea is to get down for the first time in 50 years, and then to explore that region, see if there are resources there, see if it is the ideal place to ultimately build a lunar base. The whole idea, NASA's whole idea with the Artemis program, is to have a sustained presence on the moon. And that's going to start with Artemis 3. Now, they won't stay there, but future missions would build upon it. And that's the same for China. That's the goal for China as well.
Fraser Cain, good to have you with us. Welcome to the show. Now, as John pointed out, this mission is going to go further than any other mission has been. It's going to break the record, not by much, by a few thousand miles. It will be the farthest humans have been from Earth. So far, the furthest humans have been is the Apollo 13 missions. But physics require spacecraft to do this slingshot around the moon to be able to return. So what will this tell us? And, to paraphrase Star Trek, I mean, what is the significance of going where no one has gone before?
Well, I mean, obviously going a little bit farther than anybody's ever gone before is, it's nice to add that as your list of records. But, we're sort of retreading the same steps that were made during the Apollo program. You build the rocket. You build the capsule that's going to carry the astronauts to space. You launch the rocket and make sure that everything works. Then you need to make sure that it can carry human beings for the period of time that's going to be required for an actual future successful moon mission. And so this is Apollo 8 all over again, where you've got, this time, 4 astronauts on board, and they're going to complete this flyby around the moon, demonstrate that the rocket can take them there, that the capsule can withstand the space radiation and the various forces involved, and bring them back safely to Earth. With that piece of knowledge in hand, then you can move to the next step, as John was saying, and begin preparations for a human landing on the surface of the moon. So this is so many pieces of technology are all being tested together to demonstrate that they're ready to take that next step.
Right, and Fraser, as John pointed out a moment ago, this will be a spacecraft that will be going to the South Pole of the moon. In fact, there's another mission from the private company Blue Origin that will try to land a robot on the moon's South Pole, just like the Chinese will be doing. It's near the Shackleton crater. So explain to us the importance of this part of the lunar surface.
Well, so about 10 years ago, an Indian orbiter Chandrayaan detected the presence of water mixed in with the regolith on the surface of the moon, that there is water on the moon in these permanently shadowed craters. But you only get this in places where the sun can't melt off this ice on the surface of the moon, and these are in these craters down at the south pole of the moon. And so this has become the most sort of exciting place to be able to go to the moon, because once you have water, then you have the raw material to do most of the things that are required to survive in space. You can turn water into propellant. It is the same, hydrogen and oxygen can be turned into a propellant. You can use it for drinking, you can use it for breathing, you can use it for growing food. Like, there's all of these reasons why water is so important. And if you want to support some future space-based infrastructure, you want to be able to get access to water in a place that is not on the surface of the Earth, where you have to launch it out of our enormous gravity well every time. So the future of human space exploration depends on us understanding where the water is, how much of it there is, how can we access it, how can we build up a future space infrastructure. And so all eyes are on the south pole of the moon. As you mentioned, not just what the Americans are planning, the Chinese have done the same. In fact, the Chinese have delivered a sample from the far side of the moon with one of their previous Chang'e missions. So everyone is planning this. Now with Blue Origin, there's a lot of sort of future landers, as well as a lot of what's part of NASA's commercial launch payload services program, where they're delivering a whole bunch of robotic missions to the surface of the moon to try to better understand this in preparation for that future when humans actually set foot at the south pole of the moon.
John, I want to talk about some of the plans that Elon Musk has for space. But first, what is your view on the U.S. return to the moon? I mean, why now? What is driving this mission?
Well, I think it came down to the fact that, and I was guilty of it as well. I mean, over the years, we always said, why do we need to go back to the moon? Why don't we just go straight to Mars? What was the holdup? Should have kept doing it. A lot of Apollo astronauts had told me over the years, they regretted the fact that the Apollo program didn't continue and that it wasn't built upon, and we didn't go, start making plans to go to Mars then. But the reality is, and Fraser pointed it out quite well, that you really need to do all of these other things first. If you're going to go to Mars, you better have a good idea of what it's going to take to live on Mars, to grow food on Mars, to survive on Mars. So that is, and that's exactly what both the United States and China are doing. And that's the point, because you're not really going to effectively go to Mars until you really understand what you're getting into and that you can deal with it. That's why you go to the moon. That's why you build ultimately a moon base there, and practice all of the things that you would need to do to go to Mars. You perfect them on the moon.
Right, and John, talking about getting to Mars, Elon Musk's SpaceX plans to send its most powerful rocket, the Starship, with robots to Mars this year. Of course, Musk, in very characteristic fashion, is very vocal, saying that humans need to colonize Mars. But not everyone is in agreement with that. There's the renowned astrophysicist Neil deGrasse Tyson, who thinks this won't happen because the radiation levels on Mars are far too great for survival there. What's your view?
Well, I think that, I've interviewed Elon Musk back in the day, 15 years ago, 20 years ago. And even back the times I interviewed him, this was Elon's space purpose, for lack of a better way to put it. His belief is that we have to colonize Mars and that we will overcome these other issues of radiation and, the distance from the Earth. But and that is the purpose of building Starship, the massive spacecraft that he is testing out of Texas right now. And in fact, not far from me here at the Kennedy Space Center, they're actually building a facility to start launching the Starship from here. And that's the biggest rocket, it's the biggest one ever built. Even bigger, significantly, than NASA's SLS, Space Launch System. So, it remains his purpose. And, everybody will say, never count Elon Musk out. So I would not count him out eventually getting to Mars and landing humans on Mars, and perhaps even establishing some sort of a colony. But look, let's face it, getting to Mars, that may be in our lifetimes. Establishing a colony on Mars, that's another story.
Fraser, let's talk about another planet, Mercury. In November, after 7 years in space, there will be a European probe that will enter the planet's orbit. What do you think we'll learn from this mission?
Yeah, you're talking about the Europeans' Bepi Colombo mission, which has been, it feels like it's been traveling forever. And of course, Mercury is the hardest place to reach in the solar system, which I know is kind of strange. You think you just fall. But in fact, you have to sort of kill a lot of velocity from your orbit out at Earth to be able to make it down to Mercury. So there's been a lot of orbital sort of slingshots that have been going on. But Mercury is the closest planet to the sun. It's this bizarre world that is covered in rock and metal and is sort of interacts with the sun, and is one of the places we know the least about, and yet holds many of the secrets of the solar system's early formation. And so there have been a few previous missions, but really it's been underexplored at this point, and I think Europe is really going to try to solve that and get to the bottom of a lot of the sort of geological mysteries about the surface of Mercury, as well as sort of the state of its magnetic field, and try to understand both the history of Mercury, and by doing so, better understand the history of the solar system.
Okay, John, I've got a couple of minutes left. I just want to look at something else, and there will be another astronomical event this year. It will be the solar eclipse. Now, eclipses are not rare, but it will be the first time that it will be observed in mainland Europe since 1999. It will start over Siberia and then move across over to Greenland and then finally across Spain. Firstly, will you be there? And what can you tell us about this phenomenon?
Listen, if you want to send me, I'll go for you guys anytime. I'd love to go. No, I'm not planning to do that one, but I mean, just observing them is just spectacular. It is just an incredible sight to witness, and make sure you're wearing the glasses properly when you do. But yeah, it's just, they are not once in a lifetime events, but for a lot of us, they are spectacular.
Okay, and we need to leave it there. John Zarrella, Fraser Cain, thanks to both of you for being with us. And that is it for this edition of The Heat. I'm Arnold Naidu in Washington.